In the years between the acceptance of heliocentrism in the 18th century and the discovery of Neptune in 1846, several astronomers argued that mathematical laws predicted the existence of a hidden or missing planet between the orbits of Mars and Jupiter. In 1596, theoretical astronomer Johannes Kepler believed that the ratios between planetary orbits would conform to God's design, only with the addition of two planets, one between Jupiter and Mars and one between Venus and Mercury. Other theoreticians, such as Immanuel Kant, pondered whether the gap had been created by the gravity of Jupiter. In 1761, astronomer and mathematician Johann Heinrich Lambert asked, "And who knows whether already planets are missing which have departed from the vast space between Mars and Jupiter? Does it then hold of celestial bodies as well as of the Earth, that the stronger chafe the weaker? And are Jupiter and Saturn destined to plunder forever?" In 1772, German astronomer Johann Elert Bode, citing Johann Daniel Titius, published a formula later known as the Titius-Bode law that appeared to predict the orbits of the known planets but for an unexplained gap between Mars and Jupiter. This formula predicted that there ought to be another planet with an orbital radius near 2.8 astronomical units, or 420 million kilometers, from the Sun. The Titius-Bode law gained more credence with William Herschel's 1781 discovery of Uranus near the predicted distance for a planet beyond Saturn. In 1800, a group headed by Franz Xaver von Zach, editor of the German astronomical journal Monatliche Korrespondenz, monthly correspondence, sent requests to 24 experienced astronomers, whom he dubbed the celestial police, asking that they combine their efforts and begin a methodical search for the expected planet. Although they did not discover Ceres, they later found the asteroids Pallas, Juno, and Vesta. One of the astronomers selected for the search was Giuseppe Piazzi, a Catholic priest at the Academy of Palermo, Sicily. Before receiving his invitation to join the group, Piazzi discovered Ceres on 1 January 1801. He was searching for the 87th star of the catalogue of the zodiacal stars of Mr. Lecky, but found that it was preceded by another. Instead of a star, Piazzi had found a moving star-like object, which he first thought was a comet. Piazzi observed Ceres 24 times, the final time on the 11th of February 1801. When illness interrupted his work, he announced his discovery on the 24th of January 1801 in letters to two fellow astronomers, his compatriot Barnaba Oriani of Milan and Bode in Berlin. He reported it as a comet, but since its movement is so slow and rather uniform, it has occurred to me several times that it might be something better than a comet. In April, Piazzi sent his complete observations to Oriani, Bode, and French astronomer Jérôme Lalande. The information was published in the September 1801 issue of the Monatliche Korrespondenz. By this time, the apparent position of Ceres had changed, primarily due to Earth's motion around the Sun, and was too close to the Sun's glare for other astronomers to confirm Piazzi's observations. Towards the end of the year, Ceres should have been visible again, but after such a long time, it was difficult to predict its exact position. To recover Ceres, mathematician Carl Friedrich Gauss, then 24 years old, developed an efficient method of orbit determination. Within a few weeks, he predicted the path of Ceres and sent his results to von Zach. On 31 December 1801, von Zach and fellow celestial policeman Heinrich W. M. Olbers found Ceres near the predicted position and continued to record its position. At 2.8 astronomical units from the Sun, Ceres appeared to fit the Titius-Bode law almost perfectly. When Neptune was discovered in 1846, 8 astronomical units closer than predicted. Most astronomers concluded that the law was a coincidence. The early observers were able to calculate the size of Ceres only to within an order of magnitude. Herschel underestimated its diameter at 260 kilometers, 160 miles, in 1802. In 1811, German astronomer Johann Hieronymus Schröder overestimated it as 2,613 kilometers, 1,624 miles. In the 1970s, infrared photometry enabled more accurate measurements of its albedo, and Ceres' diameter was determined to within 10% of its true value of 939 kilometers. Ceres has a surface area comparable to the area of Greenland.